Okay, so class will be recorded for anyone that misses it or wants to come back and review anything from class later. I got a few folks need their cameras on, but otherwise, getting started. Hey, I wanted to go back and I was looking at where we've what we've done already this semester. So the very first week, a little short week we had when we came back from Christmas, we had an assignment that we did together in class. You actually got the copy. I'm copying. You copied what I did, and we turned that in as an exit ticket. Basically, you turned it in at the end of class. You got 25 points. Easy start to the semester. I said I want to give everyone an easy start. Give them basically some free points. All you do is copy what I did, turn it in. We still have one, two, three, four people have not turned that in yet, and some of you were in class, or at least your Chromebook was in class. If you weren't in class, that's your problem. You're going to have to go back and watch class again because that's the only way to do that assignment now. You got to go back to week one video back in January at the beginning of the semester and watch the video from class and do the assignment because I gave the instructions during class. It's not written down anywhere because we did it together. That was the point, doing it together. So if you haven't turned in the first week class assignment, go back, watch the class video, get that done, and turn that in because I want you to have those free, easy little points. They don't seem so free anymore because now you got to take your time to do it because we did it together in class. So get those done. There are still some of you, more than four, that haven't turned in last week's assignment yet. Now, last week we watched the videos. We watched the videos last week to know how to do everything last week. Um, and I wrote the pseudocode. We'll look at that again in a moment. I gave you the pseudocode for last week. So all you had to do was follow the pseudocode and write the programs. So I mean, a lot of you got that turned in now. And you look in Buzz, you'll see it's turned in. It may not be graded yet because I haven't graded a bunch of those. They just got turned in this weekend. I didn't work over our extra large weekend. Uh, and so, the extra day off Monday, I wasn't grading papers. We all had the day off. But so some of you have turned it in, and I haven't got it graded yet. It will be graded in the next couple of days. Thursday or Friday, I'll get it graded and get it in there. But if you are still missing any assignments, go back and get those done, and don't do them with AI because I don't give you credit for letting AI write your programs. Especially these programs so far, they've been really simple. We've watched videos on exactly how to do it, and if you're using that AI shortcut, uh, you're I've had people fail last semester. I had a lot of people fail programming last semester, and they kept turning in AI programs and never learned. It's like, don't you look at your grades when you turn it in? Can't you learn? All right. This week, we have one more program that we're writing that's covers all last semester. And I'm doing this because we got so many new people. I want the new folks to get up to speed on what we've already been using in programming. We're watching videos on how to do that, breaking it down pretty simple. And for folks that were here last semester, I want you to get a good start to the semester. Not having to do anything that you haven't already learned last semester and getting a couple of program grades in there to boost your grades up, keep your grade in good shape because these are 100-point programs. Last week and this week are 100-point programs. These little 5-question quizzes we'll get into next week, 25 points. You got to do 4 of those to equal 1 program. So this nice boost to your semester hopefully will help you keep your grade up where you want it to be and get you off to a great start. So with that, let's go look and see what we have in store for this week. Let me get on the right screen here. Okay, looking at our grade screen in Buzz. So I can click on this little icon here, or you can go up to the menu bar over here. But I'll click on the little grade icon. You should have those first 2 programs turned in. They might not be graded yet. If you just turned them in this past weekend, they won't be graded yet. But it'll show that you turned it in. It'll have a submitted date, that good stuff. This first one may or may not have a submitted date because a lot of us turned it in Google Classroom. So I just entered the grade here. So turn it in Google Classroom. You may just have a grade, not have a date you submitted it. And that's fine. As long as you got the check mark and the grade, that's what you need. Okay, Should show it's submitted here, even if it's not graded. So if you're behind on either one of those, get those turned in. You're still got plenty of time. This week, we're looking at the 4.005. We did 4.00. Now we're doing 4.005. Then next week, we'll get to 4.01. So 005 comes before 01 in math. So let's go see what it shows. Go back to the activity screen. There was the first week assignment that we turned that in. Here's last week's assignment where we turned that in. Here's this week's assignment. And I've got it right here. Your choice. Now, you don't have much of a choice in this. Sorry. You have some choice. You're to write a program of your own creation that meets this criteria. Now, let me tell you right off. Last week, I gave you the pseudocode. All you do is follow the pseudocode. Pseudocode says this, so let me write this line of code. It says this, let me write this line of code. This week, I'm just telling you what your program has to do. You are writing pseudocode. Then you're using your pseudocode to write your program. So this week, I'm adding that step, and we're going to answer our postmortem questions this week. So we'll look at that on the template. In fact, I'll probably switch to the template now just so we have it all in one place. But it's the same thing. I have the directions here in Buzz or on the template, but you will need to go to the template. So let's just switch over to the template now. In the classwork tab, week 21, do this week in Buzz. Here is the more practice program that we're writing this week. Same instructions as in Buzz. All right, here is what it says that it needs to do. Here are the parameters. This is what your program must do. Write your program using Python idle. Using comments, type a heading that has your name, date, and a short description of the program. Make sure your program contains your main function. Use meaningful names for all variables. Don't just call it variable, variable 2, variable 3. No, go give it a name that means something. What is it? What is that variable being used for? Give it that name. Okay. Ask the user to enter a number between 1 and 100. Okay, the user has to give you a number between 1 and 100. Then your program must contain at least one line of code, which means you can do more if you want to. The requirements are at least one that does some kind of math, a mathematical computation using the number that the user entered. So the user is going to give you a number and your program is going to do something with it. You're going to multiply it. You're going to divide it. You're going to add it to something. You're going to subtract something from it, or subtract it from something, or you're going to take the square root of it, or raise it to some power, or you're going to take it times 299 and tell them how much their total is. I don't know what you're going to do with it. You just have to do something with that number that the user gave you, some kind of math. Then, after you do this, using a loop, and don't worry, especially if you're new, we're going to look at loops today, so you will know how to do this by the time class is over. Print, output, print the numbers 1 through 19. There you go. In your choice, you can use a for loop or a while loop, and we'll look at both, for loop or a while loop. So your output, here's what your output should be for your program. Well, this should help you write your pseudocode right here. Showing the number the user entered. So if you say, oh, you entered 61, or you entered 19, or whatever number they entered. It should also have the result of the math. When I multiply your 19 times 3, it equals 57. And your output should have the numbers 1 through 19 because you're using a loop to print those. So that's the 3 requirements on the output. And include your pseudocode. So insert your pseudocode right here. And notice I've underlined pseudo. It's not real code. You do not copy your code and put it here because your code is not pseudo code. Pseudo means fake. And we'll look at that. Submit your zip file in Buzz. Where's Buzz? Here's Buzz. So at the bottom, down here, here's where you turn in your program. Right, turn in your program. And then when you are done with your program, you need to come to the template and answer the following questions. And there's really not a wrong answer as long as you're telling me what you think. I've had people use AI to do this. What was a problem you ran into and how did you fix it? AI didn't have a problem. When AI answers this, you get 0 points. This is worth 20 points to just answer these 4 questions, and there's not a wrong answer as long as you tell me what you think. What would you do differently next time you write a program? Think about it. Put some thought. How could it be useful in the real world? Think about it. How could a program do what your program did? Where would you use that? What was the purpose of your program? Answer these. These are not AI. None of this is AI. This should be out of your brain. So I want to go back and look at last week's. Here was last week's. This is pseudocode. Pseudocode. This is what your pseudocode should resemble. Everything in blue here is pseudocode. Notice if I put that into a Python window, it's going to be error, 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 error. None of this is code. This would not run because it's not real code. It's pseudo code. It's a plan. So last week you used this plan to write real code. That's what you're going to do this week, except this week you are going to come up with the pseudocode using these requirements. This tells you what your pseudocode should be planning for. So write the pseudocode, put it right here underneath that, and then you can write your code and then answer these questions. So to write this code, we need to know how to do math, how to do for loops or while loops, and good stuff like that. So in our Google Classroom, at the top up here, Mr. Brock's how-to series. Last week, we watched in class, we watched these first 5 videos. What every program should include. How to do print statements. How to write, run, and save programs. How to create and use variables, and how to do input statements. If you don't remember any of that, you can go back and rewatch them. It's right here at the top. Right here at the top of Google Classroom. We're going to watch these next videos this week. There's 5 more videos. We're going to watch 4 of them. We're not going to watch the turtle graphics because we're not requiring any graphics today. There's no graphics needing done. We'll skip that. That's a 10-minute video. That's long. So it takes a little longer to talk about turtle graphics. So we're going to skip the turtle graphics video. But we're going to watch the other 4. How to do math calculations. How to do for loops and while loops. And this one, we don't have to do any if statements, but I want to go ahead and show you the video while we're watching these because you might want to use an if statement. You don't have to. It's not required. It doesn't say that an if statement is required in this week's program, but I want you to see this video on how to do that. Turtle graphics, I don't know. We don't have a program coming up that uses turtle graphics right now, so if we need to visit that one later, we can do that, or you can watch it on your own if you want to get into the turtle graphics. So. But we're going to watch math calculations, for loops, while loops, and then we're going to skip to the if statements. And this should give you the rest of the information you need to write this week's program. Again, like I said, if you need to review any of these, they are there for you. So, all right, let me share this in a way that you can actually hear the sound. All right, starting with math calculations. Python can do calculations for you. I've got this basic program where I've already established 2 variables, number 1 and number 2, and I've given them values of 9 and 4. I'm going to show you how Python can do basic calculations for us. So if we have, let's just call it total, that'll be our variable name, and we want to add them together, we just say number 1 plus number 2, and then we should print something if we're going to do some calculations. So if we run the program, it can add them together. 9 plus 4 is 13. If we want to subtract, we just simply subtract 9 minus 4, number 1 minus number 2, and that works fine. If we're multiplying, we use an asterisk. Asterisk multiplies these 2 numbers together. So we should get 36. There that is. If we want to divide, that is the slash
right there. Number 1 / number 2 will divide 9 by 4, and we get 2.25. All right, so that's just the very basics. Okay, now let's say I want to do some a little more complicated things, like raise something to a power, like 9 squared or something, 9 to the 4th power, or I want to take the square root. So to do that, Python has some built-in functions. So before our main function, we're going to say from math import with this asterisk after it. And that tells it, hey, I know you have some built-in math functions, and I'd like you to go retrieve those so I can use them on my program. So we add this at the beginning, and you can put a space there. It doesn't really care if you like that. From math import. And so far, doesn't change anything going on here, but we can use different functions. So if we want to raise something to a power, we have to type power and then number 1. And I say I want to take 9 and square it. So the total now is just going to take 9, because that's what number 1 equals. And I'm going to take it to the 2nd power. So it prints 81. Now notice it prints it as a float number because it doesn't know if there's going to be a decimal or not, because it could be, if this is a different thing, take it to a power, it could have a decimal. So it's just preparing that. If we want to take 9 to the 4th power, we can just say number 2 in case that changes at some point. Maybe we'll change this number, but we can take the power of 9 to the 4th power, which is going to be 6,561. So that's how we raise something to an exponent. You put the number that you want to put as the base, and then the number you want to have as the exponent. And in this case, I've got them saved as variables, so I'm just using those variable numbers. If I want to take the square root of something, then I can simply do that as well. I just change this power to SQRT. That is the square root command. And I'm just going to have one number inside there, right? Because I can't take the square root of 9, 4. I said, I want the square root of whatever the value is in number 1. There it is. The square root of 9 is 3. Now it's only going to default to the positive. We know the square root of 9 is 3 or -3, but Python will just default to the positive value on square root. We could also add another line. Total 2 equals square root of number 2. And then we can print total and print total 2. They have both of those, 3 and 2. So that's how we can use some of the functions that it has built in, or just adding, subtracting, multiplying, dividing. Loops are very useful when you're going to be repeating code over and over again to save you from having to do that. Like if we were going to, let's say, print 1 Mississippi. All right, and then we know we go print 2 Mississippi. So we're doing like a counting program, right? We want it to do all of, 10 Mississippis. We would have to do this over and over again, but we can use a loop to do a lot of this work for us. So let's talk about a for loop. For, and we have to give it a name or whatever it's going to be. For loop, we'll just call it loop, or we can call it count in range. And we have to tell it how far we want it to count. Let's say 11. And a for loop has a colon at the end of it. Okay, so now we've created a loop that will count to 11. But when it gets to 11, it stops. It will not execute the 11th time, but it's going to start counting. But this is the important part of how Python counts. Python does not start counting with 1. Python will count with 0, and I'll show you how we know that. Anything inside the loop has to be indented again. So let's just tell it to print the count. And let's see where it starts. Run the program. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, it started with 0. The last thing it prints is 10, because as it goes through the loop, it adds 1 to the count each time, or count. And it comes through the first time, the count is 0. So that's what it prints. And it'll keep adding 1 and going back through the loop until it gets to 11. This is the stop value. When you count becomes 11, stop. Don't do the loop anymore. So we can go down here and we unindent we'll say print the loop ended, just so we can see when it ends. See, now it does that at the bottom. The loop ended. So anything that's indented will be part of the loop. If we indented this by mistake, look here, it's going to print that every time. 0, the loop ended. 1, the loop ended. 2, the loop. So anything in the loop is indented. When you are through with it, the indentation should be the same as the F in 4. So print count. So this is really useful. So if we wanted to do that Mississippi thing, let me clear that. We can say print the count plus space Mississippi. But remember, if we're printing a number and a string of letters, we have to tell it, treat the number like it's a string of letters. This will give it an error if it tries to print a number and letters together, unless you use the str command. So don't forget that. But let's try this. Clear, run the program. 0 Mississippi, 1 Mississippi, 2 Mississippi, all the way to 10 Mississippi. You're like, well, what if I don't want to start with 0? That's weird. No one starts counting with 0 Mississippis. You're right. So we can tell it start with 1. If we do a 1, 11, now it'll start counting with 1 and it will stop when it gets to 11. So what's this right here? 1 Mississippi, 2 Mississippi, all the way down to 10 Mississippi. Then the loop ended. Like, well, that's pretty cool. Well, other things you can do with it, if we wanted to count by 2s, we could say, okay, go to 21 now and count by 2s. So this says start at 1, stop when you hit 21, and count by 2s. 1 Mississippi, 3 Mississippi, 5 Mississippi, 7. Maybe we just want to use the even numbers. We want to start with 2. Okay, let's try that then. Clear. 2, 4, 6, 8, 10, all the way to 20 Mississippis. Okay. Going by 2s. So you can start with any number you want. You can tell it to end. And notice that it wouldn't have got to 21 because that's the stop value. And count by however many you want. Count by 6s. 2 Mississippi, 8 Mississippi, 14 Mississippi. So that's how a for loop can help repeat these lines of code instead of having to do all of those print statements. We did one print statement and the loop took care of it for us. So, and you can do anything in a loop. You could anything you want to do. If you're doing turtle graphics and you want it to keep drawing the same shape over and over again, you may have had turtle move forward 50, turtle move turn left 10 degrees, and it would just keep doing that over and over again for as many times as your loop runs. So just use loops when there's something you want to do over and over again and don't have to repeat the code. And the for loop is a great way to do that if I know exactly how many times I want it to run. So again, if I want it to run 10 times, or I can start at 1, go to 11, and if I'm counting by 1s, I don't have to put that third number on there. But nice, simple for loop. A while loop works very similar to a for loop, except for we use a while loop when we're not sure exactly how many times we want it to loop. A for loop, we told it exactly how many times to loop, but with a while loop, let's play with that. So if we were doing something like, let's do this. Let's say total equals 0. So I've set this variable up called total. And I'm going to do a loop that says while total is less than or equal to 21, run this loop. And inside the loop, it's important that I change the total or I'm stuck in a loop forever. If I don't ever do anything with the total and the total stays 0, the program will get stuck in this loop and never end. So I would do something in here to say, all right, I'm going to use the random integer command to where it is going to generate a number between 1 and 10. Okay, and then I'm going to print whatever that, let's see. I'm going to save a variable, number equals, and I'm going to print what that number is. So every time it's going to generate a number between 1 and 10. And I'm going to print it, and then I'm going to add that to the total. Whatever the total was, add the number. Okay, so looking at this loop now, we've got a total of 0. It'll go enter the loop, and the first time it checks, the total is less than or equal to 21 because it's 0. So we generate a number by using the random integer function. We haven't really studied this, but it's in that Python API where you can click and see all the commands used. Random integer, and we can tell it the range. So now I'm going to print that number, whatever it generates, and then I'm going to add it to the total. So it'll generate a number, let's say 6. It'll print 6 and then add it. And when it comes back up here and checks, the total is still less than or equal to 21. So it'll run through the loop again, and it'll keep doing the loop until the total is larger than 21. Now, we haven't studied this, but to use the random integer function, I do have to import that. From random, import rand integer. It's kind of like from math import, we have to import the math functions or the turtle functions. If I want to use the random function, I have to import that. But this is the while loop using the random integer between 1 and 10. So let's run it and see how many times it goes through the loop. So first time, it chooses the number 9, and then 6, and then 3, and then 5. So it runs through the loop 4 times. Let's run it again. Well, this time it ran through the loop 5 times because 1, 2, 8, 14, 4. So we had total of 3, total 11, total of 15. After 4 times through the loop, it was still less than 21. It was only 15. So it ran the loop 1 more time. Now it totals 23, so it exits the loop. So if we run it, each time it's going to be different number of times that it runs. 4 and 5. Oh, there are only 3 that time because it chose large numbers. But we're using a while loop instead of a for loop just because we're not sure, in this case, how many times we need to do the loop, because it's going to change each time because I'm using random integer. But a lot of times there's other code that you write that you're not really sure how many times, especially if instead of a random integer, I'm saying import. So let's do this like an input number. I can delete this if I'm not using the random. So let's do this. If I said,
yeah, I'm going to pause this real quick because this is important for this week's program, because you're going to have the user input a number between 1 and 100. This will apply to you right here specifically.
Number equals integer input, enter a number. Now when I run the program, it's having the user enter a number. I'm going to enter 5. I went through the loop. I got to enter another number, 6. Oh, 65. I hit 65 by mistake. So if the user's entering numbers, we don't know how many times it's going to run. Because if I'm entering 1 and 2 and 1 and 3 and 2 and 1 and 3 and I didn't enter a number. I just hit enter by mistake. So we're having the user enter a number. It could be that they're going to go 1 and 3 and 2 and 4 and 2 and 1 and 3 and 2 and 3 and 4 and I finally got over 21. But see, it had to run the loop many times because we don't know if it's an input, how long. If they enter 25 right off the bat, the loop's done. So while loops are very useful also in repeating code over and over, but we just use it when we're not sure exactly how many times. If we know for sure how many times we need the loop to run, we would use a for loop instead. Let's review some of the basics graphics that Python has built in. Yeah, I just have a basic program set up, and I have my main statement, my main function defined. And the only statement in my main function is this input statement where happy equals input. Are you happy, yes or no? When you run it, it'll pop up this window and you type yes or you type no or whatever. And it doesn't do anything because I haven't told it to do anything. But that's the only thing I have in there. So I want to check, and I want to print a statement based on what they enter. And that's where an if statement comes into play. So we can use an if and use a parentheses, and let's check what they entered for happy. So if happy equals yes. So this is how, colon. This is how an if statement works. You have your if, and then in parentheses, you put what you're checking. We need to check, is this true? If this is true, and a colon has to follow it at the end. But we're saying if happy equals yes. Now with an if statement, you have to use two equal signs. If you use one equal sign, that's where you're assigning a value. Like I'm assigning whatever they type to the variable happy. But if I want to check it, I have to use two. Or you can use less than or greater than, or not equal is an asterisk equal. If it's not equal to yes, okay. But greater than or equal to doesn't make sense when you're checking for words. But if I had numbers, that would make sense. But I'm going to check to see, does it equal yes? And so anything I want to happen has to be indented, right? So if I don't indent it, it's not going to be part of the if statement. Everything that you want to happen, if this condition is true, has to be indented underneath. And here's what I want to happen. I want to print, since you know it, clap your hands. Okay, so now let's run this. Run program. Are you happy? And I'm going to say yes. Well, since you know it, clap your hands. And what if I don't say yes? No. Nothing happens because I didn't tell it to do anything. Notice this is indented. If I didn't indent this, it has an error because it says, I don't know what to do if that's true. You didn't give me any commands. So this has to be indented so the if statement knows, all right, if this is true, what do you want me to do? And I can list multiple things here. I can have several lines. Set check equal to true, whatever I want to do. Loop or value equal value plus 1. I'm keeping track of how many people are happy, and I'm adding 1 because this person said they're, I can do everything I want to do, but everything that's indented will happen if this is true. If it's not true, nothing happens because I haven't done anything else. So if I want something else to happen, then I can put an else. All right. So if it's true, do this. If it's not true, do this. Print. And let's see. I will say something like, here, I got this little statement up it. Quote. And, all right, let's run this. I'll show you what I put in there. Run program. No, I'm not happy. A smile can lift your spirits because the act of smiling, even if forced, triggers the release of mood-boosting chemicals like dopamine and endorphins in your brain. So I just put something there. Smiling. Yeah, I just changed it to smiling. Smiling can lift your spirits. So yeah, so it'll only do that if I don't say yes. If I say yes, since you know it, clap your hands. Oh, and then it has an error. Local variable value reference before assignment on line 11. Oh, because I've got this value equals 1. And value did not exist. It's like you haven't defined this variable. So I'll delete that. So that's why it created a problem if I say yes. So, but yeah, everything I want to happen should be indented under the if. If it's true, everything I have indented underneath there happens. If it's not true, it'll go here. Now, I got an extra I in it. Not true also includes, what if I type, yes, I am. Are you happy? Yes, I am. It's going to assume that this is not true because it's looking exactly for YES. Anything else I type is considered not true. It does not equal yes. Yes, I am is not the same as yes. So it'll default. So that is one of the pitfalls of programming, that you have to tell it exactly. That person has to type exactly what you type, right? They can't say absolutely or I am or anything besides YES will default it to the else. So that's one caution in there. And that's nothing you can really correct other than make sure you tell what choices are. I put YES so they don't just hit, if they just hit Y, it's going to default to a no because that's not YES, right? See, it's going to print this again.
So that's the important thing about the input statement. Tell them exactly what to type. Show them exactly what you need. So when they do type that, your if statement works properly. But you can use if statements to check all kinds of things. And you can add the else if needed. If you don't need it to do anything when it's not true, you don't need the else. That's an optional part of it. If I don't want it to print anything, I can just leave the if statement. And then when I type something, it just doesn't do anything. But that is the basics of how if statements work.
That covers basically everything, with last week's included, everything you need to know to be able to do this week's program. If you're having trouble, this is a short week because we had Monday off with that extra large weekend. There are no more A days this week, but you can email me, and if we need to get together on Friday, I can open up a meet and set a time with you to help you on Friday. Tomorrow I'll be working on getting things graded, but you can email me and see what my availability is the next 2 days. Even on B day, I might have some time that we could get together if needed. So if you're having trouble with this, don't wait till the weekend. Work on it before the weekend so you can see if you know what you're doing, and let me know if I need to help you. But otherwise, our time's about up. Programming 2 will be coming in here, so I'll let you guys go. Have a great week. We'll see you on the snow days. It'll be snowy Monday, maybe. I don't know.